In an earlier video, we talked about what random variables are, and we briefly touched on what are the two different types of random variables. So there are two. So continuing on from that video, the two different types of random variables, the main two types, are discrete, um, discrete random variables, and continuous random, sorry, random variables. Yeah. So basically, what are discrete? So we're going to focus firstly on discrete random variables. Let me just change the color a little bit. Let's go yellow. Um, so yeah, so let's focus first on discrete random variables. So discrete random variables, discrete random variables are basically variables that have a countably finite or infinite number of possible values. So basically, we should be able to count them. So we should be able to count all the possible outcomes of that particular random variable. So these have finite or infinite countable, which is the keyword here, countable possible outcomes. So what this basically means is, let's say we have a random variable called x. Let me just change the color again. Yeah, so let's say we have a random variable called x. Yeah, and x defines the number number of chips in a packet. So obviously, let's assume that the number of chips in the packet are only whole, so you can't have half a chip. So you can have zero chips. So basically, so basically x can take on the values of zero. So that means there's no chips in the bag, one chip, two chip, and so on, and all the way till basically infinity. So if you have infinite chips in your bag, then you're a very lucky person. Um, so basically, the main point to note here though is that the possible outcomes that x can have are countable. So there's 0, 1, 2, 3, 4, and so on. Another example of a discrete random variable is basically, let's say in an insurance context, um, let's say y. Y is a random variable that defines the number of insured policyholders, so number of people that you insure, who will claim, who will make a claim in the next month. So these are the number of people that you insure and how many out of those people will claim over the next month. So basically the values that Y can have would be 0, so that means no one can claim, or one person claims, two people claim, or all the way up till n, where n is the number of total policyholders that we have, that we're insuring. So clearly you can't have, let's say, half a person or a quarter of a person that claims, because that is literally impossible. So discrete random variables don't have to have outcomes that are whole numbers. So for example, let's say if a die is marked as half, quarter, 1/6. So the outcomes would be y equals half, quarter, 1/6, and whatever the other three faces are. But that's still a discrete random variable. The key point here to note is that the random variable is countable. So that means we can count the outcomes on our fingertips. So now this is different from a continuous random variable. So a continuous random variable, let's talk about that now. So a continuous random variable is basically a variable that has outcomes which are uncountable. So basically, all the outcomes of that particular random variable can be described on a number line, but they can't be counted on fingertips. So the outcomes are uncountable. So you can't count them on the fingers. So what would be what so that's the keyword here. So what would be an example? So um let's say we have, let me just scroll down a little bit. Um, yep, make some space. Yep. So let's say we have a random variable z that basically describes, so that equals to, let's say the exact cost, exact cost of a new house in Sydney. So the exact cost of a new house in Sydney. So now, what are the values that Z can have? Well, let's say, so Z can go all the way from, let's say it costs $100 to buy a house, because let's say a tent is technically a house and you can buy a tent for $100. So that's a possible outcome. Or it could be $101, or it could be $102, or it could be $1 million. So it could be $1 million as well. But since we're looking at the exact cost, it could also be $100 and 1 cent. $100 and 1 cent. And so let's graph this on a number line. So the outcomes for Z, let's say there is the $100 outcome, and there is the $100 and 1 cent outcome. Now, even between these two outcomes, there could be a third outcome. There could be a third outcome. So let's say $100 and half a cent. And now, even between these two, $100 and $100 and half a cent, there could be another outcome for Z, which is $100 and a quarter of a cent, and so on. And so this is basically an infinite sort of arrangement. Sorry if you can't see that a little bit. Um, so that's basically essentially the difference between discrete and continuous. So with discrete random variables, we can count all the possible outcomes that exist. But with a continuous random variable, basically, the outcomes are uncountable, because we can't count what the exact cost of the house in Sydney would be on our fingertips. What are the possible values that Z could take? We can't take count those outcomes on our fingertips. So the reason we differentiate between discrete and random variables is because it impacts how we calculate things. So the concept is broadly the same, but for example, when we are calculating, let's say, when we're calculating moments, which I'll cover in a future video, or if we are calculating probability, which is essentially a key application of random variables, or any other calculation. The broad concept remains the same. However, the individual ways of calculating these will be different, and I'll continue this discussion in future videos. Thank you.